everyone! Welcome back to Knowledge Chronicle. Today, we're diving into a truly fascinating and life-saving mechanism. How your kidneys are not just filtering organs, but brilliant regulators of your body's balance. We'll break down how the kidney function is controlled, the role of hormones, and how different organs like the brain, heart, and kidneys team up to maintain stability inside your body. Stick with me till the end. This might just change how you see your own body. So, first, why do we even need to regulate the kidneys? The kidneys are the body's filtration plant. But beyond just filtering waste, they control blood pressure, maintain the correct amount of water and salts, electrolytes, and balance body fluids. If this system fails, it can lead to dangerous conditions like dehydration, high blood pressure, or swelling. To prevent all that, our body has set up an intelligent hormonal feedback system, involving the hypothalamus in the brain, the juxtaglomerular apparatus JGA in the kidney, and even the heart. Let's unpack this whole system, step by step. Let's start with the brain, particularly a part called the hypothalamus. Scattered throughout your body, you have special sensors called osmoreceptors. They detect changes in blood volume, water content, and ionic concentration, like sodium levels. Now imagine you're sweating a lot, or losing fluids due to diarrhea. Your blood becomes more concentrated. That's when these osmoreceptors get activated and alert the hypothalamus. The hypothalamus then tells the neurohypophysis or posterior pituitary gland to release a hormone called ADH, antidiuretic hormone, also known as vasopressin. What does ADH do? It travels to your kidneys and makes the walls of the distal tubules and collecting ducts more permeable to water. So instead of losing water in urine, your kidneys reabsorb it back into the blood, conserving water. This reduces urine output. That's why it's called antidiuretic. Also, ADH causes slight constriction in blood vessels, raising blood pressure, which helps increase glomerular filtration rate, the rate at which kidneys filter blood. When your water level returns to normal, the osmoreceptors deactivate, and ADH release stops. That's negative feedback in action. Now let's head to the kidney itself, where another superstar system is waiting, the juxtaglomerular apparatus, or JGA. The JGA monitors blood pressure, blood flow, and glomerular filtration rate inside the kidney. If blood pressure drops, say due to blood loss or dehydration, the JG cells in this apparatus release an enzyme called renin. Here's where things get even cooler. Renin converts a protein in the blood called angiotensinogen into angiotensin 1. Angiotensin 1 is then converted to angiotensin 2, a powerful vasoconstrictor. This angiotensin 2 does two major things: narrows blood vessels, increasing blood pressure, and signals the adrenal glands to release aldosterone. What does aldosterone do? It tells your kidneys to reabsorb sodium from the distal tubules, and water follows sodium by osmosis. This increases blood volume and hence restores glomerular filtration rate. This entire loop is called the renin-angiotensin-aldosterone system, a master regulator of blood pressure and fluid balance. You might be surprised, but your heart also helps control kidney function. When there's too much blood volume, the atria of the heart stretch and release a hormone called atrial natriuretic factor, or ANF. ANF causes vasodilation, meaning it widens blood vessels, reducing blood pressure. It also inhibits the release of renin and aldosterone, putting the brakes on the RAS system. So ANF acts like a balancing force, preventing the system from going overboard. Let's quickly recap. ADH from the brain saves water and raises pressure. JGA and RAS respond to low pressure by conserving salt and water. The heart releases ANF to lower pressure when blood volume gets too high. All of this works in harmony to keep your blood pressure, water levels, and kidney function in check. Isn't it amazing how different organs communicate and work together to maintain homeostasis? If you found this as fascinating as I did, don't forget, your one like, share, and subscribe will help us create more valuable content. Thanks for watching Knowledge Chronicle. See you in the next one.